టు బ్రైట్స్ వర్క్ యూట్యూబ్ ఛానల్. మనం ఇంతవరకు సిరీస్ రెజొనెన్స్ సర్క్యూట్ గురించి తెలుసుకున్నాము. ఇప్పుడు మనం ప్యారలల్ రెజొనెన్స్ సర్క్యూట్ గురించి సింపుల్ గా తెలుసుకుందాం. ప్యారలల్ రెజొనెన్స్ సర్క్యూట్. Here one coil is taken. This is the coil connected across the capacitance in parallel. This is the C, this is the R, this is the L. All are connected to the supply voltage source V. Here any parallel circuit act as a resonance circuit, means the reactive components of the currents is equal to 0. Okay, that is the condition of the parallel resonance circuit. Once again, reactive components of the currents is equal to 0. Here phasor diagram written. Here RL, this is the here flow of current is IL, IC is I. Here take reference P, x-axis, y-axis. This is the VL sin theta. This is the IL cos phi. That means current through the inductor or coil, that cos phi component is in phase with the supply voltage. This is the VL. Means total inductive currents is divided into two components, that is IL cos phi. IL is divided into IL cos phi into IL sin phi. This is the vector sum. Here this is the IL cos phi is in phase with the voltage. Here is the IL sin phi. This is the vector sum. The vector sum is, this is the IL. Here angle is phi. This means flow of current in inductor is lagging behind the supply voltage. Okay, this direction. This is the I of C. It means in capacitive current is ahead of the supply voltage. This is the 90 degrees. Here is the coil. That's why some internal resistance is there. Coil. This is not a purely inductive circuit. This is the combination of the resistance and the inductive. That's why this is the coil. That's why the current voltage and current relationship is not exactly 90 degrees. In pure inductive circuits, IL is 90 degrees lag behind the supply voltage. Okay, this is not the pure inductive circuit. That's why this is the IL. This is the IC. As for resonance, as for parallel circuit condition, ఎనీ ప్యారలల్ సర్క్యూట్ ను మనం రెజొనెన్స్ గా యాక్ట్ చేయాలి అనుకుంటే అప్పుడు రియాక్టివ్ కాంపోనెంట్స్ కరెంట్స్ IC minus IL sin phi both are equal. is equal to 0. This means IC is equal to IL sin pi. Okay. Here, as for equation, IC is equal to flow of current in capacitor. Thus, Y is equal to, here is the voltage in parallel circuits. In each parallel branch, voltage is same as the supply voltage. That's why IC is equal to V by XC. Next, IL is equal to V by Z. Here, sin pi is equal to, as for impedance angle, sin pi is equal to XL by Z. As for this coil, sin pi is equal to XL by Z. Okay. V by XC is equal to V into XL by Z square. Here voltage cancel. Z square is equal to XL into XC. Here Z square is equal to omega L by omega XL is equal to 1 by 2 pi FC, that is equal to omega C. Z square is equal to L by C. This is the equation. Okay. As for here, Z square is equal to L by C. Here Z is equal to, as for circuit, Z is equal to R square plus XL whole square. So R square plus XL whole square is equal to L by C. Here XL square is equal to L by C minus R square. This term is taken to left hand side, right hand side. Okay. Here XL is equal to 2 pi F naught L whole square is equal to L by C minus R square. Here 2 pi F naught whole square is equal to L by C minus R square by L square. That is equal to 2 pi F naught whole square is equal to L by C into L square minus R square by L square. This is 2 pi F naught is equal to, this is resonance frequency. Fr is equal to, L is cancelled. This is 1 by LC minus R square by L square under square root. This is the resonance condition formula. Okay. This is 2 pi F naught. Here resonance frequency is equal to Fr is equal to 1 by 2 pi into root LC. Here R is neglected to 0. R is neglected to 0. That's R is equal to 0. That's why resonance frequency is equal to 1 by 2 pi root LC. This is the resonance condition formula. Okay. Once again, I will explain about that. Here is any parallel circuit, it act as a resonance circuit, means the reactive components of the currents are equal to 0. IC minus IL sin pi is equal to 0. This is the, as for phasor diagram, IL is divided into two components, IL cos phi and IL sin phi. This is the IL. This is the IC, flow of current through capacitor. If both are in equal magnitudes, so This is the active component, this is the reactive components. React component, this is the active component. That's why reactive components both are in net reactive is equal to 0. That's why IL minus IC minus IL sin pi is equal to 0. That is called IC equal to IL sin pi. Here, as for the circuit diagram, flow of current to the capacitor is V by XC. Here written. IL means this is the total impedance. The flow of current in inductor is equal to V by Z. Here sin pi is equal to XL by Z. So this equation is solid. V by XC, all are substituted in V by XC is equal to V by XL. Both are V cancel and right side and left side. Here Z square is equal to XL and XC. Here Z square is equal to XL is equal to omega L by XC is equal to 1 by 2 pi FL. That is 1 by omega C. Omega is cancelled. Z square is equal to L by C. This is the equation number 1. Okay. All of you know that Z is equal to R square plus XL O square. Here is substitute that R square plus XL square is equal to L by C. XL square is equal to L by C minus this term is goes to the right side. Then minus R square. XL is equal to 2 pi F naught L. All of you know. This square is equal to L by C minus R square. Here 2 pi F naught whole square is equal to L by C minus R square by this L square is numerator is goes to the denominator and right side. That's why L square. L is cancelled. R square by L square is equal to finally 2 pi FR is equal to square root of L by C minus R square L square. Here R resistance is neglected. Very low value compared to the XC and XL. That's why resonance frequency is called 1 by 2 by root LC. Okay, all of you know. Next, graphical representation. Graphical representation of parallel resonance circuit. Okay, here we taken x-axis and y-axis. Here inductive react in this circuit, inductive reactance, inductive susceptance B is equal to minus of 1 by XL. Capacitive susceptance is equal to B is equal to XC. This is omega L, here is omega C. Okay, here reference frequency is taken on y-axis. Thus frequency is omega L is equal to 2 pi of L. So here both are in, here omega L is inversely proportional to the supply frequency. That's why here 1 by minus of 1 by omega L proportional to the frequency, direct frequency. This means supply frequency and 2 pi of L both are in inversely proportional. Another this is negative side. Is now here this is the negative quadrant. So here is taken when frequency is increases, omega L is decreases. Initially frequency is 0. So this is frequency 0. Then inversely proportional means omega L is maximum. This is the omega L. minus of 1 by omega L circuit. No. That's why frequencies goes on increasing, omega L decreases. This is the rectangular, thus curve shape is rectangular hyperbola. In parallel circuit, conductance is constant, that is G. Conductance is constant. Here, capacitive susceptance means V is equal to omega C. That is equal, here omega C is directly proportional to frequency. That's why this is the omega C curve. At the time of supply frequency is 0, then omega C is capacitive reactance is 0. Goes on increasing supply frequency, then omega C is also increases. The resultant current of the 1 minus of 1 by omega L into omega C, both resultant curve is appeared like this. This is omega C into minus of 1 by omega L curve. This is the hyperbola. The curve shape is hyperbola. Okay, this is the resonance frequency. In parallel circuits, in parallel circuit, current is minimum at resonance frequency condition. Okay, this is the resonance frequency condition. This is the Z curve. This means in series resonance condition, at resonance frequency condition, current is maximum, impedance is very low. Here is reciprocal of the current. Here means at resonance frequency condition, current is very low, impedance is very maximum. So this circuit is anti-resonance circuit. This circuit, the parallel resonance circuit, also called as a anti-resonance circuit. Okay, this is the graphical representation of the parallel resonance circuit. Okay, next we are comparison between the resonance circuit and parallel series resonance circuit and parallel resonance circuit. There is resonance circuit. This resonance, parallel resonance circuit. Here is finally impedance is equal to Z is equal to R. Here Z is equal to admittance is equal to conductance. Power factor is unity. Series resonance circuit also act as a resistance. That's why power factor is unity. Here also admittance is equal to conductance. So power factor is unity. Reactance XL minus HC. Here reactive components of reactive components of currents equal to 0. This is the condition. Current is, here is maximum current flow. Maximum current applied in the series resistor circuit. Here is minimum current flow at the at parallel resistor condition. Current is minimum. Here impedance is small. Here is impedance is Z is high. Impedance is high. Here FR is called resonance frequency is called 1 by 2 pi root LC. Okay. Here 1 by 2 pi square root of 1 by L minus R square by L square. This is the resonance frequency formula. Okay. Here resistance is neglected. Then this is here resistance is some case neglected. Okay. Magnification. In series resonance circuit, voltage magnification is occurred. Voltage magnification. In parallel resonance circuit, current magnification is occurred. Current magnification. ఇన్ఫర్మేషన్ మీకు నచ్చితే లైక్ చేయండి, అలాగే నా ఛానల్ను ఇట్లాంటి కంటెంట్స్ కోసం సబ్స్క్రైబ్ చేయండి. ఎవరికైనా మీ ఫ్రెండ్స్కి ఉపయోగపడుతుంది అనుకుంటే ఈ ఇన్ఫర్మేషన్ను షేర్ చేయండి. థ్యాంక్ యూ.